In the last video we looked at half wave rectification, and in this one we're going to look at full wave rectification. The difference being we have 4 diodes instead of 1 diode. We still have our smoothing capacitor here to smooth out the ripple, because you're still going to have ripple there even with these 4 diodes rectifying it. And the way it's done is, if you follow these arrows here, this is the current flow on this circuit when the live wire is in a positive direction, which means it's up here on this half of the cycle. The current will flow this direction, and it will come to these diodes, and that current will try to get to the negative. It's attracted to the negative side of the circuit, so it's trying to get there, and it can't get down there through that diode. That diode blocks it. It needs the anode of the diode facing it, so it sees this one here, and it can go through this way, and then off here to the smoothing capacitor and to the load, and the current flows through the load back out the negative side of the capacitor, and it comes up here to the bridge rectifier again. And if you look at this, it's got an anode here of a diode, and it's got an anode here of a diode, and you could say, right, it could flow back there, but it's not attracted to the positive, it's attracted to the negative. So this is the negative side here, so the current will flow down through that diode and back here to the neutral wire, which is negative with respect to the live. And the next cycle, these polarities are reversed. Now our neutral wire is positive with respect to the live, which is now negative, which we're talking about here. And the current flows in this direction, and then it comes to these diodes. It can't go through that diode because that cathode blocks it. It comes to this diode and it has an anode, and that allows it through. And if you see, it's back on the positive side of this smoothing capacitor and comes down through your load, back in, back out this way, bottom of your smoothing capacitor, comes up then to your bridge rectifier, and it has to go to the live now, which is negative with respect to the neutral, which was positive. So it's not going to go back down this way, it's going to go up this way and then back to the live. The current changes direction here on these 2 wires here and in the bridge rectifier itself, but here around the capacitor and the load, that current stays, goes in the same direction. I'll just put up the in the live is positive. Now here we are. Current flow here has changed direction, but here it's still going the same direction here through the load. Also, this capacitor here does smooth out that ripple that would appear here on the output of this bridge rectifier. The ripple would be something like this. It goes from 0 volts up to 385 peak, roughly, back down again, and then up again for the we'd say this here is the positive cycle of the sine waveform, and it comes back down, and of course then the bridge rectifier then brings the negative, the neutral one, but the neutral wire is positive. It comes up here as well. With the half wave rectification, this part of the sine wave is missing because it's only doing half of it. If that capacitor was faulty and it wasn't put in the circuit, that is the type of thing you would see on your oscilloscope. with the capacitor in, we can see what happens is you'd have a waveform something like this. It charges up and discharges, charges, discharges, and charges up and discharges. It's nearly a straight line, and to all intents and purposes it is a DC, a 385 volts DC voltage, and not like the input, which is an AC. The voltage goes below this 0 volt line.